Great. So yeah, we have our URN now that can be stored as a single value. So let's see what this now looks like. So we had our let's get our resource back, and so again, our resource has a URN property. Our resource has a URN property. So there's an interesting thing happening right now. So our struct, so far we've had, we didn't have to declare an initializer for a struct when, so we declared a struct, it had properties, and we just got an initializer for free with all of the properties. So this was working before. We had a URN. We were instantiating a URN with a string value. We now added an initializer to our struct. Once we add an initializer, we lose the default initializer. So we to get that back, let's just add the initializer back that we had before. That takes a string value and self.string value equals string value. So we'll talk about initializers probably next week. So one of the quirky things with Swift is if you're getting initializers for free, for whatever reason, there's a couple of other ways that you might be getting an initializer from some other place. Once you define one initializer, all of the ones that you got for free don't exist anymore, and you have to implement them yourself. So because we created this initializer inside our definition of URN, we now have to add this initializer back. So this should work right now, and this is now how our resource is stored. So let's go back to Sublime here. This is how it was stored before. This is how it's stored now. So this is exactly what we wanted. Our URN is now stored as a single string instead of this dictionary. So this is what all of the init from decoder and the encode method work that we've done. It's paid off, and we now have a way to encode and decode a struct as a single value. Okay, so let us, maybe as a little aside, there's another way that we can retain the initializer that we got for free here, and that is by by adding the protocol adherence to our URN struct through an extension. So we haven't really talked about extensions, so let's introduce it here. So this is a great place where we might use an extension. So let's say this URN struct was defined by the standard library that is available to us in Swift. So we wouldn't be able to add protocol adherence to encode and decode if it didn't exist already. So one example, that we'll see later today is UI color. By default, we can't store a UI color. So just to prepare us for that, let's see how we could add protocol adherence to a type that we didn't declare. So let's remove the encode and decode from the definition of the URN, and let's create an extension with the encode and decode extension. So URN, we're extending the URN type, and here we're adding the protocol conformance. So, and here we're just going to copy and paste, or cut and paste our two methods. Okay, and then as I hinted, we can get rid of this initializer that we had to add back. So yeah, what did we just do? So before we maybe go through what happened here, let's see that we can still run it. Yes, we can still run it. Okay, so what did we do? So we have our URN struct, And let's pretend it was, we don't have access to the source code. So how do we add codable conformance to this URN struct? We can write an extension to URN where we're adding protocol adherence, and then we can just add the protocol adherence right here. So this is a super nifty way of being able to add functionality to existing types, and it doesn't end with protocol conformance. This is a huge, a really nice language feature that we can just extend to any type. We can add not just protocol conformance, but any kind of functionality that we want to add to a type. We can just write an extension to a type, and we can add those properties on there. We'll see that a little bit later. But yeah, so protocol conformance is a great way for using extensions. But yeah, it's not just limited to that. We'll see that a little bit later. Okay, so yeah, because we added this initializer in an extension, we actually get to keep the free initializer that we get with a struct. So we didn't have to add that initializer into our URN property. And yeah, so we'll talk about initializers probably next week. Great. Okay, so yeah, so what have we been able to do so far? So we stored a cat instance that had some properties that can also be stored, and then the default implementation is just that each property gets stored as a key value pair in our JSON dictionary. If we want special behavior from one of those key value pairs, so in this instance we had a type. So our resource struct had a type that we also declared, the URN type. The default behavior was that this URN type then would be stored as a dictionary. We wanted some non-default behavior, and we wanted it to be stored just as a string value. We have to add the protocol conformance ourselves and implement how it should be coded and encoded. Okay, so let's. So I hinted at extending types that we don't have access to. So yeah, we did create this type ourselves. Let's work with a type that we don't have access to. So let me actually turn some of this. Let's see, I don't want anything to print out. So we have our cat still printing out. Let me turn that off as well. Great. Great, okay, nothing's printing out. Okay, so let's, I talked about UI color already. So let's see what happens if we create our own type that has a type that we don't have access to, and we're trying to store that. So let's see what happens. So let's create a car. So struct car, and this car has a color property. So let color UI color. Okay, so let's see. We'll create an instance. So let my car equals. So I actually don't have a car currently. The only car in our household is my wife's car. I broke our other car. So, but the car that I had was red. So we're gonna create a red car, and let's see what happens if we try to store this. So what were the steps in being able to store to be able to store a type that we created? So what is the first thing that I have to do? So to be able to store something, what protocol do we have to adhere to? Let me go back up. Codable, yes. So to be able to store it, just encodable, but we want to do the whole shebang. So we want codable, encodable and decodable. So we want our car to be conforming to the codable protocol. So let's see what happens now. So type car does not conform to protocol decodable, and type car does not conform to protocol encodable. So that is surprising because I'm saying I'm adhering to this protocol, and it was working before. So for all of these, it was working before, but now it doesn't work anymore. So So I've said it already, but so who can figure out why I can't do this right now? So what are the, for me to be able to just say that I'm adhering to the protocol codable, what has to be true for all of its properties? Anyone? They have to be codable. Great. So yeah, from this we know UI color does not conform to the protocol encodable or decodable and encodable. So how do we add protocol conformance to something that well, just does not adhere to the that color that protocol. It's a type that we don't have access to. So we could go the route where we are adding protocol conformance to UI color. It's always a little bit funny to add protocol conformance that is not ours, so codable is not our protocol, to a type that is also not ours, because Swift might add it later and then it conflicts. So actually a safer thing to do in this case would be to implement the codable protocol from scratch, how we've done for our UN type. So let's do that. So we're adhering to the codable. Let's create an extension again. So extension car, and here we're adhering to the codable protocol. We need to now adhere to the decodable and encodable protocols. So I'm just going to copy paste the initializer and the encode methods, and but I'm going to remove the implementations. Okay, so we want our car to be codable. So now we need each of its properties to be codable, or we have to define our own implementation of how to store this color. So let's not start with the initializer. Let's start with the encoding. So let's see what. So how do we store a color? So how right now, if you had to define a color, how would you define a color in computer terms? So if you had to give me values for a color, how would you give me those values? RGB. So that's what we're going to use. We're going to store these RGB values ourselves in a color dictionary. So we're going to have an RGB. I guess we'll have an RGB dictionary. Oh, so string, and then so the way that the RGB values can be retrieved from our color are in CG float. Oh, is it CG float? Which one is it? We'll see this in a second. So, okay, so we're trying to encode our car. Let's extract the RGB values from our color. So color dot CG color dot components gives us the color components. So let's maybe just look at what this does with the color red. So LED. I think I have to. So we have our color red, UI color dot red. Let's see what we get if we're printing out those values. So print color red, and then we have so for the color red. we get these RGB values. So we get 1, 0, 0, and then we get another one here. So the 1 at the end is the opacity. So 1 means it is a non-see-through color, and 0 means it is completely opaque, and values in between are in between values of opaqueness. And then, so yeah, from the 1 and 0 properties, we can infer how the color is represented within the language. So a 1 value is full color, so in this case red. So we have full red, and then we have 0 RG. So we have 0 green and 0 blue. So this is clearly red. So 1, 0, 0. We're dealing with a red color. So let's by calling this CG color property and components, we are getting the color components of our color red. So when we're encoding our color, this is what we want to have access to. So we have our car's color, RGB values. We now have access to our RGB values. Okay, so to encode them, one second. Here we go. So to encode them, we want to create. So we have this RGB. We have these RGB values. Let's create a dictionary. RGB array. Let's store it as a dictionary, so it's a little bit easier to read. So RGB dictionary. Let's just RGB. And then it is of type string and CG float. So the RGB array, if we're inspecting it, we get the values are of, not of regular float or double, they are of type CG float. So whenever you're dealing with drawing on the iPhone, you get these weird CG values. You can convert them back and forth to doubles, but whenever you're dealing with drawing, you have this intermediate type that I believe comes from just the legacy environment of drawing. So a little bit annoying, but so not necessarily. We don't really have to worry about it too much because they almost behave the same way as just double. Okay, so we have our RGB dictionary here. So let's add the individual keys. So we have red, so RGB array. So this was the first element. Green. Let's just use R, G, and B. RGB array and RGB. Great. We'll disregard the opacity for now. Okay. So we'll disregard the opacity for now. So it looks like our color.cgcolors.components actually returns an optional array. Not sure how that makes sense because theoretically all colors that I can think of have those values. So we'll have to deal with this optional case. So let's do a guard else block, and so now we can see what if something goes wrong encoding, we have to we now have the pleasure of throwing an error ourselves. So how do we throw an error? Let's define an error first. So car encoding error. So errors in Swift are enums that have the associated type error, and then you can car encoding errors. We can have a couple here. But in this case we just have one. So color had no RGB components. So this error we can now throw ourselves. So throw car encoding error, color had no RGB components. Okay, so we created our own error type here with one. So our error has one subcase here, which we can throw in our encode method if there's no RGB component. I have never seen a color component that didn't have those values, so if you find one, let me know. Great, so now we are dealing with a non-optional RGB array, and then so now we can construct our RGB dictionary here, and now we can store this dictionary so that we can retrieve it later. So we are encoding. Okay. So let's go back to this. Let's go back to our resource that we tried to store. So somehow we had these coding keys here. The way that by default the coding keys are generated are by property name. So we had URN here, for example. So the name of the property, that is the coding key that we get for our JSON string. Since right now we are implementing everything from scratch, so the encode and the decode function we are implementing from scratch, we have to define, or we get to define those ourselves. So there is a so this is all what happens in the background for us by default when we don't have to implement the encode and decodable protocols. But yeah, so now we have the pleasure of creating it ourselves. So the coding keys are also an enum. So coding keys, they have the raw value of type string, and then they adhere to coding keys, which is also coding key, which is a protocol that helps the encoder and the decoder work with turn these into actual keys. So here we have our, so we want our color dictionary to be stored with a color key, and that should be enough. So we have a coding key. We have coding keys now, and now we can encode our we can encode our car instance. So we are following along pretty much. So it's pretty similar to the encoding and decoding that we did for the URN, where we asked for a container first, and then we decoded or encoded the values. But instead of a single value container, we are going to ask for a container, and we are providing coding keys. So let container equals encoder.container, and here we're providing the coding keys that we want to use. So coding keys.self. So these are the coding keys that we're providing. and we're asking for a container with those coding keys. So there's a little bit more here than what we had before in our encode method for our UN, but it's pretty much the same. We're asking for a container, and now we're going to encode values into this container. So this is the next step that we're going to do. So into our container dot encode. Container. So it has to be mutable container dot encode, and here we're having our RGB values, and here's the coding key that we want to use. We want to use the color coding key. So this is the only coding key that we have here. And again, this one can potentially throw an error. Okay, so let's just clean this up a little bit so that we can see it all in one. So yeah, to encode our car, we have to deal with the fact that our color is not, we can't store it right now. So we have to store the color some other way. We're getting the colors components, the RGB components. We're turning those into a dictionary, and then so these steps are very similar to what we've done for the URN type that we defined before. We're asking for a container, and then we're adding our RGB array that our RGB dictionary to the container, and we're saying that this dictionary should have the color key. Great. So now we have the pleasure of decoding. Now we have the pleasure of writing the decode implementation as well. So let me actually move the coding keys above here, and let's undo what we did to encode our car. So how do we undo this? So for the UN, we again asked for a container, or we asked the decoder for a container. So container equals decoder dot container. We asked for a single value container for the URN here, so we have to undo what we did for encoding our car instance. So we're asking for a container with the same coding keys. So that way we get the same values back that we encoded. So yeah, we're asking for a container. So let's, does this one? So this one also can throw, so we have to add the try keyword. And then we get the values out of the container. So let values equals container. So actually these are the these are already the values. Sorry, I apologize. Okay, so we have our values from this container. So now let's get our color back out of this. So let RGB dictionary dict. So we're trying to get our values we're trying to get our color out of these values. Decode. We're trying to get a dictionary of type string, and then CG float. Was that it? CG float. 4-key dot color. And I believe this one can also throw, yes. Okay, so now we have our RGB dictionary, and then so now out of this dictionary we have to get, so something I'm doing wrong. 1 second. Yes, thank you. That would have taken me a while to see. Okay, so we have our dictionary. So let's get our RGB values out of this dictionary. So God So we'll get all three values out. So let red equals RGB dict red. Let green equals RGB dict. Here, I'll just do copy paste. Let's do RGB. Okay, so now we have our RGB values. Again, we have the pleasure now of throwing an error if we can't decode this. We can't decode a proper color dictionary. So we can add. Let's maybe change it to car coding error. So car coding error. And now we can add a second case. So case JSON had no RGB dictionary. So let's we throw car coding error dot JSON. Okay, so now, again, we're doing the same thing. Oh, still an error here. Yeah, we're dealing with a type. So we're using the name of the type that we want, and then we have to add the self. Okay, so a little bit of boilerplate here, a little bit of tedious getting things out of something. So again, we have the decoder. We're asking for the container with coding keys. From this container, we're getting our RGB dictionary out again, and then from this RGB dictionary, we're extracting the RGB values, and then so now we have the ability to set our color property on our car. So color equals UI color, and there's a red, green, blue, and alpha component initializer. So RGB, and then we didn't encode the alpha component. We just set it to 1. Okay, so that was lots of boilerplate, a lot of tedious massaging of types. This is what we had to do with everything that we wanted to turn into data or store about 1.5 years ago. So the dry, all of this dry thing that we, all of this dry working out of things, you hardly ever have to do only if there's something that can't be, that is not yours, and you have to add codable conformance to it. Normally, you just have to add the keywords codable. Great. So let's see if we made any mistakes. So yeah, I guess we don't have to print this color out anymore. So let us do the same thing that we did before. So let's car data. So encoder dot encode my car. And then let's see if we can get it out again. So encode so this one can throw. So try, and again we'll use the exclamation point. We don't really want to use that, but just for convenience right now. And then so let's display the car data that we get. So string print string data car data encoding .utf8. So let's see what we get. So we have our encoded car, and this is exactly what we wanted. We have, I'll move it to Sublime again where we can see it a little bit better. So we have our color key that we said we wanted. We have a dictionary. We have a dictionary of values of float values. In this case, I guess just integer values. And this is how we So this is what we did from scratch. color wasn't encodable, we added the encodable codable conformance so that we can store our color as this dictionary. Great. So just to go full circle, let's see if we can also decode a car again. So let decoded car equals decoder dot decode car dot self. So this is again the type that we want. We're asking the decoder to create a car, and we're doing it from the car data. And let's print out our decoded car, and then so UI colors don't have a nice representation when we're printing it out, so we won't be able to see that it's red, I believe. Oh, okay, well, I guess it's not as bad as I thought. So since we looked at the representation of the color red, we know that this is red. It has 1 for red, 0 for the other color components, and 1 for the opacity. So yeah, we have our car instance that we got back from our data that we had encoded previously. Okay, so we went from very simple, where we just had to add the keyword codable, which is hopefully most of the time when you're dealing with trying to turn something into data, to not as bad, where we had this special type, the URN. So where's it? So we had the special type URN, where we wanted the type to be stored as a single value in our JSON dictionary. So this wasn't too bad. Pretty simple. To full on lots of work to add conformance to a type that is a little bit more complicated. But yeah, we needed to store it anyways. And then yeah, so again, this is how we had to store. This is pretty similar to how we had to store things about 1.5 years ago. Cool. I know this was a slightly more dry part of the lecture. I just wanted to show you that. So yeah, this is how you store things as data. This is how you can store them as user defaults. The encode and decode conformance, I always have to look up. So if you're running into this, you'll probably have to look it up as well. Yeah, so don't worry about memorizing all of this. It's just, yeah, know that, yeah, you can, if something doesn't conform to encodable and decodable, there's a way to have it conform by implementing it yourself. Great. So any questions on storing things, or I guess turning things into data? And then the one way that we've seen so far of storing something is in user defaults. Great. So let's take a break. Let's take a 10-minute break, and then let's see how we can pass data around to view controllers with our city app. And then if we have time, so I think we might be running out of time, I also wanted to use what we just had, what we just learned to store the cities that we've looked up, so that they persist, so that you can see them next time. So we might not be able to get there, we'll see. Okay, so let's come back at 8:50, and then we'll see how we can pass data around between view controllers.